that's the place to send it. If you have anything hateful, come see me in the pub, or I'll send you my email address at the end of the presentation. Hands up anybody who's actually heard of Forward. Wow, more than I actually thought there would be. Okay, keep your hands up if you know what we do. Wow, like even better. It's extremely difficult to describe what we do. This is our website. We argued for a long time about what went on to describe what it is. So the easiest way of describing it is there's lots of small businesses within the company. If you would like to know more, feel free to come and chat to me at the drinks in the pub afterwards. The content of this talk really comes from stuff we've been doing at one of the companies within Forward, which is Uswitch, which was a business we acquired about 2 years ago. It's a price comparison website. I think we're actually the second largest comparison website in the UK according to Hitwise. I forget who the leader is, but we're also the leading switcher of energy. So again, quick audience participation. How many people have actually used Uswitch for switching something or buying a product? Oh, nice. Was it good? Ah, yeah, mediocre. That's what we strive for. So if any of you people actually switched your energy in the last 18 months or so, you will have been using some Clojure-based code that we put in production, 18 months ago. So that's Uswitch. I can wax lyrical later at the pub. Users as data. The title of the talk, slightly cryptic, but it's really a nod to a wonderful talk that Mark McGranahan gave at last year's Clojure, which I missed because I was getting married. It's a good thing I was getting married, but it was a shame that I also had to miss Clojure. But watching the video was fantastic. His talk was titled Logs as Data, and he kind of alluded to some generalizations about treating things as data, and I'd like to talk about how we've been applying that to users and behavior and all kinds of stuff at Uswitch. It's interesting, actually, that lots of the talks today have been focused around eventing and data and states and stuff. Like Zach's talk was fantastic earlier. I missed Max's. But I think there's an interesting kind of serendipity of surprise around all of this stuff. When I'm talking about this stuff, I'm really talking about the building of data systems. So tools and applications and systems we build to understand what's going on inside our products, what's motivating our customers, all of the stuff that tells us how we can build better products. So I'm going to start by covering a little bit of what Mark covered for those that haven't seen or weren't fortunate enough to attend. So, everything is data. The wonderful thing about Clojure is the emphasis on the essence of data and how everything is in its kind of rawest form. Everything is data. So we all know that code is data. In this case, we can see the homo-iconic beauty that we're all used to, which is that our programs themselves are data structures. And because they're data, we can manipulate and extend them with macros and use all of the same libraries that we use for building our applications to modify the programs themselves. So, code as data. We have data as data. So that, this might be a way of building an abstraction that describes me. And note the use of a sequence to describe my mood. However, given today, I'm going to say that it's extraordinarily hot. So I'm thoroughly looking forward to a cooling off drink in a bit. Sorry? Yes, extremely hot. Yeah, there's no way of expressing extremely hot. I'm not really sure what I would do. We also have builds as data, right? So I'm assuming most people are probably using Leiningen, maybe a few people using Cake. So this is actually the start of the project file for the thing that we built that powers the energy pricing part of the website. It's been updated since we started it 18 months ago, but it's amazing how data kind of exists everywhere throughout the kind of the Clojure ecosystem. So even the tools we used are often expressed as data. So everything is data. By treating and keeping the data in its most essential form, without being, having to go through kind of all kinds of extraordinarily specialized interfaces and constructions, We can build our applications upon, a few small, simple core abstractions like maps and seeks and so on. Yeah, I forgot to click. So data in its most essential form, we can build our programs upon those kind of core abstractions like maps, sequences, and functions. And by doing so, we get to make the most of this extraordinary general library of stuff that already exists for us to extract the kind of useful power out of that data. So as I said, Mark's talk was titled Logs as Data, and his contention was that if we looked at what you traditionally think of as logging, which you could reasonably expect to tell you something about what's going on, then actually it doesn't really fulfill any of those, what's the word, like checkpoints. It doesn't really meet any of the criteria for useful data, right? So there's nothing that tells us what those two hyphens mean, so it's just lost unless you kind of understand the structure of your code. There's a connascence, right? So you can say that two things are connascent if, when you change this thing, you have to change another thing. And there's a connascence of position in the sense that you have to know exactly where, what anything in any given position means. And you're talking about kind of string encodings, right? So you've tied the data to its representation. So it doesn't, it's just not that useful. But it gets even worse, because most of the time you talk about logging, people actually mean files. They mean files on web servers or application servers or database servers or something. They're all kind of hidden away, and they're locked away from being any use to you, unless you start having to do extra work to pull them up. So interesting again that there's a lot of kind of growth in this kind of area, things like Ryman and Laminar and so on. So with the data inside log files, you have to physically go off and look and try and understand the world, and lots of that the kind of temporal flow that you would normally could normally take advantage of, you have to kind of reintroduce after the fact. So Mark's contention or point was that logs and log files were really a poor abstraction, and actually you should be treating logging as streams of events. So you kind of raise the generality to consider them as unbounded sequences of data rather than log files. And so because of this, the poor abstractions and so on, that actually the kind of current power that existed with logging and with understanding data was significantly less than the potential that you could build by treating them as data. Given that Clojure embraces lots of the abstractions that we would find valuable, we could actually build lots of interesting systems by treating logging as streams of data. So this progression from log crunching on Hadoop or whatever to streams of events. And through doing that, you fully embrace this notion of time. And again, I think that was something that Zach also raised, that time is fundamental to an event. And that most of the time, when you're just looking at something like with a snapshot of state, you miss that, and that's a massively poor abstraction. So, users as data. I think if I go back to when we started doing the work we were doing at USwitch, we see exactly the same limitations in the way that we were treating data as Mark highlighted in the way that logs were being treated. That you kind of confounding the notion of the data that exists with the way that it's stored and the way that you access it, and by dealing with only what exists, like now, and the kind of mutation that tends to exist inside kind of complex ETL craziness. So again, this notion that the current power that we get from traditional data systems is massively less than what we could potentially do through using, being obsessed with current state, being obsessed with batch processing, and embracing these kind of, poor abstractions and the poor way that we traditionally used to do these things. So, I showed you this slide earlier. If you think actually about who a user is or what a user does, for us it's people sitting at home or sitting in the office and using the website and looking at products and comparing prices and entering in consumption values and the way that they interact with our product. If you compare that kind of very fluid, interactive notion with actually what we used to do with data systems, you have some kind of enormously simplified thing that looked like this. So eSwitch used to be a kind of traditionally enterprise system, this kind of big monolithic C# and .NET application where you had, I don't know, I'm pretty sure it was close to 100 binaries that made up one deployment, and it would take at least like half an hour to like synchronize the files around the 16 machines that used to run it. It's just insanity. And so the big problem with this picture is that if you want to understand what's going on, you can't look at the database that's running your website, because as soon as you start doing any complex analysis, you start introducing load that causes problems to the front-end servers. The other issue is that you kind of end up, so through that restriction, you end up introducing new abstractions inside the ETL. So anytime you want to look at it, you're actually looking at some kind of further mutation of something that occurred. And by that point, you start kind of introducing this like lossy process that makes it extremely difficult to look back retrospectively with any with any degree of resolution. So actually, when I was thinking about this, is anybody familiar with the term muddling? Muddling. When you have a mojito or something, there's a stick with little bits on the end, and you put the lime and the sugar in and some mint or something, and you use this muddler to kind of squidge it all together, and then throw the kind of liquid ingredients afterwards. And I think I would much prefer to instead of calling it ETL, data muddling, because it's the notion that you're kind of smushing your current state into something that you can then put off somewhere else, and it's irreversible. It's a one-way operation. And actually, because of some of the technology choices and the things that we were using, that's just the way that it had to be. But that kind of thing, really inhibits your ability to look in detail at what's occurred. And it's that loss of resolution that makes it extremely difficult to do very detailed cross-sectional research, which is absolutely fundamental to being able to say, let's ask some general question about the way that people are interacting with our products and try and turn that into something that, into a testable hypothesis that we can then run some experiments on and improve the product that we have. And as I said, this mutation is brittle. It's a one-way thing. It would frequently break. When it did break, you could never figure out why it broke, because by that point everything had moved on. And if you realized there was a mistake in that muddling, you were done for. So that kind of the combination of the data and the mutation inside stuff that's very difficult to touch introduces all kinds of problems with repeatability and being able to inspect and understand what's going on. So has anybody seen this picture? Does anybody know what this picture is? So there was a wonderful blog post by Michael Nygaard, now of relevance, on the subject of big data systems. And there's a part in his article where he talks about the notion of panopticons, that traditional data warehousing was this kind of panopticon approach. So I actually had no idea what panopticon, I don't actually know if I'm even saying it right. I had no idea what a panopticon is, but it's actually a design for a prison. So you have this watchtower in the center, you have a kind of space around, and then the cells that go around the outside. And the idea was that it was a way of reducing the cost of kind of manning these prisons on the basis that you had one central point that would give you complete visibility across everything that sat around you. So the idea was that you would have maybe 3 or 4 guards watching out over like all of the prisoners, but because there was like some kind of device in the middle that would make it impossible for the prisoners to see the guards, but possible for the guards to see the prisoners, that would encourage prisoners to behave properly because they would have no idea whether they were being watched. It's a wonderful metaphor, given the idea that data is this wonderful thing if you can surface it and provide the tools for people to access it. And so much of traditional data processing and data warehousing is compared to building a data prison. So really what Michael's point with this was that you spend so long kind of trying to build this one thing that tells you everything that's going on, and it just kind of turns into this absolute kind of money burner. And I think that's definitely something we saw, where we had like a whole team of DBAs. We had, God knows, we had like four or five, enormous machines trying to store the data that is kind of mutated and of low resolution that you can't really answer anything anyway. And actually, the thing that exists is this database in the middle that acts as an integration point, but it essentially becomes a kind of choking point. So there's another really good presentation that Martin Fowler and Rebecca Parsons of ThoughtWorks gave, I think at QCon last year, or maybe it was this year. And they said that actually, that often the way that you would try and integrate kind of systems and applications from around an enterprise would rely upon this enterprise data model, like a common language that would sit in the middle. And the problem was that actually people didn't see it as just common language. It turned into this integration database. And so everything becomes restricted and limited and controlled by this one thing in the middle. And so, again, you have teams of DBAs whose jobs it is to ensure that everybody moves in the same direction. And that's not something we wanted to embrace. We wanted to embrace like a heterogeneous, fast-moving, interesting world where people could go off and do interesting things and not worry about having to all form together. So does that data, does that database to those kind of object relational mappers, does all of that stuff mean we're treating data in its essential form? Not really. And not only that, but those abstractions change, through all the kind of ETL process. And so the data that's actually happening and the data you're looking at are entirely different, and they go through this kind of opaque craziness in the middle. Are we embracing the principles of few simple abstractions and general libraries that let you access it? No, you're having to go to write SQL, business enterprise, integration, package, transformation, stuff, and you're kind of intermingling and confounding all kinds of things together. So you're essentially kind of investing in and pursuing this idea of like a one place that's going to give you the truth. But that's actively hurting us. So that was the world we found. What we wanted to do was to try and think about the way that we handle data and the way that we built data systems based on the kind of philosophies and the things that we kind of learnt to love through the kind of small experimental stuff we've done with Clojure over the kind of 18 months or so. The joy of Clojure. So the first big thing was the notion of this kind of functional separation of computation and data. The cocktail muddling of data that occurred through the ETL stuff made it extremely difficult to understand what was going on. And what's more, it made it very difficult to then kind of retrospectively look back and apply different models to that data. This slide really should be called, what Clojure taught us. What Clojure's philosophy taught us. So, the functional separation of mutation states. The other big thing is that, that data is immutable, that everything is immutable. Like, just because somebody changes their name or, like, goes on the website and enters in a different postcode than they did a second ago does not mean that they didn't enter it in the first place. And so all of the kind of traditional handling of application states was fundamentally flawed. You're kind of continually just overwriting records and losing all of the data that tells you something about what that person was doing. So that was a massively fundamental thing. And the other thing was treating data as data, trying to break down the notion that you needed to have kind of complex, crazy object systems for being able to just get at data. So what we wanted to do is to try and kind of take all of that and apply this notion of time, to try and fully embrace the notion that people are interacting with our products, they're doing things on the website, they're looking at products or running comparisons or looking at results, and all of that stuff is valuable. And at the moment, we were just kind of discarding it away because it was too high volume, it was something that was too difficult to look at. So very much all down to again, this idea that it's just the sane handling of state. So if we're building data systems to try and understand our users, how do we do that by treating data immutably and avoid all of the ETL crazy modeling stuff that we were so used to. If we try and take a look at it through Clojure size, what would it teach us about the world? And I think for us, it was the realization that actually users are, in and of themselves, an abstraction. They're a concept that we introduce. And actually, you could view that abstraction as a function of the interactions that they have on our websites. And so actually, we could even apply different abstractions to different kinds of people. You don't necessarily have to have, this notion of just one user that interacts with one product or one user that interacts with a different product. You can apply all kinds of different models over exactly the same data to tell you something about what's going on. So yeah, users are an abstraction in and of themselves. And actually, it's based upon this kind of trail of data that they produce as they're clicking around and doing things on our website. And so we can actually separate the two. So rather than building a database that has a user table that we're continually overwriting data into, actually we focus on producing data as people are doing things, and then we use that to then derive what we mean by a user. We can separate data and the computation and abstractions, which essentially boils down to exactly the same picture that people will probably have seen all over the place, which is the separation of time, state, identity, and the description of the epochal model of time. So the thing that's so nice about this is the implicit separation of the computation from the mutation state. And so actually you can boil down the abstractions, you can boil down what a user is to a fold or reduction over a kind of succession of states. And this, it's actually like earth-shattering when you come to realize that it means that you can isolate the two, because it means you can actually have competing models of users. You can explore the data in a much more valuable way. You can try out different things. You can say, that people that come to our site and look at stuff over an hour are the same as people that come to the site and interact, maybe once a day and then, in another week's time or another week's time. All of that stuff would be extremely difficult to achieve if you're fundamentally bound to the idea that you're editing a user in a table. So actually, when you look at it like this, so I know I've written user as the identity of a succession of states, but actually really what's a better description is that the user really is the function. It's the application of some insight or abstraction on the data that exists. Really going hot now. Maybe I'm just nervous. So, yeah, if the function reflects the model of our users, then we can actually apply multiple models over exactly the same state. Which brings us to the point that actually data is not just the current state. And so it's not saying, what's in my session table now, or what, if I look at a user at this point, what is it? It's the succession of all of the data that leads up to that makes it interesting. And the thing that actually got me interested in this originally was this book. Which is, I don't know if you can read it, but it's called In the Plex. Has anybody, hands up if anybody's actually read it? Okay. So it tells the story of kind of Google's early days up to, well, recent days. But the interesting thing for me was that I'd never worked on kind of artificial intelligence or machine learning problems or anything like that. And so the notion of being able to evaluate the quality of something that seems so specific to a particular kind of query on a particular concept seemed a very difficult thing to achieve. Like, how, do you just run it for everything and then look at it and see whether it makes sense, or is there some like quantitative way that you can evaluate it? And so in the Google book, they talked about how they hired a guy who suddenly turned on weblogging, and they started being able to use all of the weblog data to try and infer whether people were happy with the product that they produced. So they could, you could look at the log results for a particular query, and if people immediately moved to page 2, then you knew that they weren't satisfied with the results on page 1. And that inference led them to believe that actually, the results for that query were, poor compared to other ones. And that for me was quite a kind of inspirational thing, because it tells you that actually there's lots of data that we're missing by obsessing about current state, that tells us valuable things about whether our products are meeting the expectations of our users. And the other fundamental part of it was that you could actually make these kind of much larger kind of inferences or assumptions based on behavioral data. So there's nothing to say whether a user was happy with a search result or not happy with the search results. You use an intermediate thing that tells you whether or not that's true. So you can learn an awful lot from relatively small bits of data. And as I said, that was a really interesting thing. It got me thinking, how could we apply it to USwitch? Is there something we can do to understand whether people stay within the top parts of the tables or whether they do lots of comparisons? And again, all of that stuff would have been impossible with the data systems that existed and this obsession about just keeping the current state of the world. So I think the other crucially interesting thing is this notion that data has a separate timeline, and so we're used to kind of fundamentally binding applications and data together. Your application has its own application database that may then replicate it to some other database. They're bound things, right? But actually, by treating users as abstractions over the data that they produce, you can actually see that the data that's produced has its own timeline, it has its own value. So there's lots of cases where we built applications to kind of meet a very kind of specific customer niche, and actually we've just turned them off because they're not, they don't convert highly enough, or they're just not a valuable source of traffic. But actually, the data that they captured is valuable, and because we want to get rid of that application doesn't mean that we want to get rid of all of the data and all of the stuff that we learned about the users in the time that it was operating. And so actually what we want to have is a kind of an acceptance of applications as ephemeral things and isolated away from the capturing of data. And so data has its own timeline, it's its own value. The concepts that it represents are entirely distinct and separate from the applications that generate them. So really what we want to do is to kind of shift away, again going back to the stuff that Mark was talking about with logging. We want to move away from this notion that the data on users or the things that exist in our products are things that we have to go and look at periodically. We don't want to be bound to just current state snapshots. What we actually want to do is to kind of embrace the temporal nature of what people are doing and to build data systems around those kind of temporal events. I actually forget why I put this back in. I'm going to blame Marco for springing this on me late, but basically, I think it was the idea that we kind of had this discovery, we had this existing data prison that was actually slowly collapsing under us and becoming extremely operationally difficult because it was actually tied together. It wasn't just an analytical system, it actually ran past the business. So we needed to get away from that as quickly as we could. So, again, to quote the wonderful Michael Nygaard, that instead of focusing on building this kind of panopticon of data, that actually what we should be investing our time in is making it easy to extend the sources of data that already exist and to add new sources of data. And there's a tension between that and this notion of a data warehouse. It's actually a really, really good article. I would thoroughly encourage everybody to look at it. It goes into more detail about research methods and the way that you can use data to drive your thinking. So we want to get away from this notion of a panopticon and to something that's more dynamic. So I think really what we're talking about is, again, a shift from data warehousing to what I've been thinking about recently as this notion of an ecosystem. I think ecosystem has a kind of nice biological fluid metaphor to it. So I don't know, it seems okay now. I'm pretty sure if somebody comes up to me in the pub later and says, no, you're wrong, then I'm willing to accept defeat. But it's the shift from something that's rigid to something that's fluid. So what do I mean when I say data ecosystem? I mean something which, in a funny way, almost solves the data expression problem. So we want something which is a kind of a community of systems, a community of processes and programs and applications and kind of supporting infrastructure that can produce data that's valuable to the rest of the community. So the idea that you kind of encourage interaction between things that can participate rather than a kind of centralized point of control. So actually you can talk about this using another extremely general model that Mark presented in his talk, which is this notion that you have some kind of aggregator process that joins the producers and the consumers of data together. And so for us, producers would be things like the energy comparison website, the service that sits behind that does all of the pricing and all of the comparison. It would be like external services that send email and I don't know, when people, like the click tracking systems and all of that stuff. And really it's also a reflection on the way that we want teams structured. We don't want an organization that's made up of one person coordinating and controlling where every team goes. We want teams of loosely coupled, small teams of loosely coupled people that can get on and build products that solve their problem, but can also add value into this data ecosystem. And then on the consumer side, we can build monitoring systems, reporting systems. We can do ad hoc analysis in tools like R. We can use, actually I'll show you some examples of some stuff we did with R and Cascalog and Esper and so on in a bit. But essentially, like through treating this kind of centralized event stream of stuff that's going on, you can actually build really valuable systems out of exactly the same data that your products are operating on. And so I think the thing that makes the notion of an ecosystem different from a warehouse is this kind of organic growth that's, I don't know, maybe kind of loosely curated, but fundamentally kind of organically grows without any particular kind of plan or vision. And the idea being that we want to encourage participation, we don't want to enforce it. So if people are getting useful data, then they can produce it. If they want to consume that data, they can. If they don't care about people's email addresses, they don't need to worry about cracking open some crazy object model. They can just ask for the bits of data about email. So this was really joined into this observation of the stuff I said earlier about eventing, which is that actually the thing that makes all this possible is by emitting smaller pieces of data. We're not concerned with looking at the current state of an entire user object that lists like the products they viewed or like their entire address history or like their credit card information or whatever. What we actually are interested in is smaller pieces of data that arrive as and when people provide them that we then combine together. So again, this separation of the abstraction model from the data that derives it. And it also means that you kind of minimize the footprint for that integration. So it actually also works quite neatly as a data integration device. So using smaller events with simpler pieces of data provides a nicer integration model between all the systems. So to give an example, you literally just have events that would carry some kind of correlating identifier like a user ID or whatever, along with the payload. So if people fill out email addresses, we send events with email addresses. If people fill out postcodes, we do that. The interesting thing is that from those small pieces, you can actually derive interesting information. So if people enter in their postcode, you actually can derive, kind of geo-coordinates. So you can start building up maps of where people are distributed around the country. You can look at whether you get lots of visitors in certain regions that correlate with when you're running ad campaigns or whatever. The data becomes its own thing. It becomes this kind of simple, small footprint for integrating between the applications, and it means that you encourage participation in the interactions that people care about, rather than forcing people to take on kind of large binaries for dealing with all kinds of crazy, complex user stuff. So, as I said, users are really the special meaning we ascribe to data, and by separating the two things, we can do some funky things. So what I'm going to do, 33 minutes, I've got about 5 minutes left. So I'm going to show some examples of the stuff that we built since we introduced this model of integration and this model of data, and a shift towards this data ecosystem metaphor. So how we've used it. The first example is actually a monitoring app that we wrote ages ago that uses Esper and Socket.io. So we have an Esper process that's running, that's receiving events that are coming live from monitoring systems. So we'll get kind of IP traffic flow through routers, weblog data. We'll get kind of events from other bits that are interesting. And we use this to just kind of keep an eye on what's going on the website currently. So at the moment, we just list the The response time in milliseconds, it turns out that's not really a good thing to look at because some requests take an extremely long time and others are extremely quick, so it's a really poor measure of throughput. But at the time I recorded the video, that's what was there. We have the success rate, we have the failure rate, so we can actually use that to understand what's going on in behind the scenes. The reason that this is valuable is that we acquired a business that was running on PHP on some other hardware. They got mentioned on some morning television show. Their traffic went through the roof. And at the time we were using Google Analytics as real-time thing to understand what was going on. And if you looked at that, it was extraordinary. We had this kind of huge increase in traffic, and there was lots of people interacting with the site, and it was all wonderful. We actually used this tool to realize that 1 in 10 requests were erroring. And so analytics told us that the world was great. This told us that there was a severe problem with a particular back-end system. So I think, again, if the data wasn't surfaced, if it wasn't easy to get at the data, if we had to pay this kind of large integration cost, we would never have understood it. We wouldn't be able to move in a kind of agile fashion to build little tools around the sides that tell us and help us build the products. So I was using a little Esper wrapper that I wrote. If anybody's interested, that's where it is. It's pretty early days, but it's enough to stick maps of data in and get maps of data out. The other little tool I wrote was a little command line thing. So we have maybe 30 or 40 EC2 instances, I think, that run all of the websites and the web applications and back-end systems that we use. To be able to know what's going on which application server or what's serving my request, I thought I'd whip up a little command line tool that would tell me what's going on. So I don't know how well you'll be able to see this, but basically the terminal on the left is just a kind of printout of messages as they come in. The browser on the right is just hitting requests. So it means that I don't have to go, this idea of not having to go and look at data. It's kind of data coming at you, and it's something you can look at in real time. It's not that interesting. It's basically just a dump of stuff from Nginx. But what's interesting is actually that when I enter my postcode, in a minute it'll zoom in and highlight. Yeah, happy days. That's a kind of message from Nginx, but it's intertwined with all of the data that comes from inside the application. So I can see the message payloads that came from the application to say, this is my email, this is my postcode. So it's the aggregation, the joining of a data stream together that tells a picture about what's going on. And that really was just so that I could know that when I was writing code and deploying stuff, that everything was working and everything was doing what I thought it would. I said at the start that one of the things that this kind of smushing of current states to form your reporting did was it limited the resolution at which you could look at stuff historically. So this is a pretty funky chart that, so I work on a team, so my name's Paul, I work on a team with 2 other people also called Paul. So this is the third Paul's diagram that shows, it's a chord diagram that shows the interaction between the kind of parts of USwitch. So I'd move away, but then I don't think anybody will be able to hear me. So the kind of green inner bit is everybody that transacted within Energy. The blue bit, I think, was mobiles, and the red bit is broadband. But it essentially means that we can draw a picture over time that tells us if somebody transacts in one part of the website, where do they go next? Where are the kind of flows of traffic? And it lets us look at it and say, well, maybe we're doing a poor job of offering the comms products to people that do Energy. In actual fact, it shows that the comms stuff is relatively well integrated. Energy is extremely generous, but doesn't really get back much in return. So again, it's using all of the event and kind of data that we've been collecting, processing it in Cascalog, and kind of embracing this notion of time to draw a picture that we would never be able to have done with the system that we had historically. And this last thing really is a similar thing, but it's a network flow diagram. So that the size of the blob shows kind of relative size of the number of visitors. It's actually only high volume pages as well, but the green dots are the Energy ones. I think red again is broadband and blue is mobiles. The interesting thing is the way that the diagram is organized is using a particular method that tells you where people originate and the direction that people flow. So the more centrally it is, the more likely that people are to kind of start there and then progress outwards. So again, it kind of tells us the same kind of thing that, for USwitch, energy is the, well, it looks like a universe diagram, so it's the center of the universe for USwitch. So, users as data. What I hoped I had talked about, and I'll find out at the pub later whether this succeeded or not. I'm too frightened to go onto Twitter. That we want to get back to the essence of data and embracing events and data rather than these kind of compound, complex object models that we're used to get away from this notion of dealing with current state only and embracing this notion of time, and that actually events and immutable data are lovely, lovely ways of building data systems out of loosely coupled applications. And with that, I'm going to say thank you. So I think I'm out of time. But
you can take a question. Why?
I'm compelled to also say that if you're interested in this kind of stuff, I would love to speak to you later. I would love more people to build data systems with me. We're big fans of Clojure. Come speak to me afterwards. Yeah, and questions. Yes, sir.
Okay, so you moved away from sort of centrally archiving a big warehouse and then pulling partial information back from.
Yep.
To a more event-driven process where data is flowing between the students and seeing it all in real time. You're still storing history somewhere, so is the student story local?
So the question was, we're moving from a centralized state to capturing events over time, but we're still centralizing the events. Is that?
So are you still
Yeah.
storing history?
Yes, exactly. So.
Centrally or with each individual student?
So we're storing the state centrally, but it's not. It's essentially just bytes on disk. It's the event stream as it happened with the state as it occurred and with the data that we have at the time. Yeah.
So whenever you want to actually do sort of processing that you haven't thought of against historical data, you replay the event stream against
Yes. So we would replay everything, but actually what we have are systems on the side that for every time we think of something interesting we want to know, we'll build a system that's aggregating and running that kind of batch computation over history and building snapshots, and then you can essentially fold against the snapshots. So you don't need to reprocess 4 years. You could if you wanted to, but actually you can use these intermediate steps. Yeah. Thank you.